Good morning, good morning, good morning. Welcome to my session about DirectQuery in Analysis Services. We will spend 1 hour and 15 minutes looking at the features that we have in Analysis Services, which, by the way, are also available in Power BI, most of them. I will try to clarify which one are used in one and the other. My name is Marco Russo. I'm from Italy, as you can hear from, as you can listen from my accent. And for a living, I work on SQL BI, on Power BI, Analysis Services. I wrote several books about DAX, in particular, the data modeling, and the black one that you see is a book about Analysis Services, which is for Analysis Services 2016, but is equally good for 2017. During this session, I will explain what could be the differences between the two versions and also with other versions. You can also see that on this website you will find other courses and training. If you are interested about Analysis Services or DAX, you can find many information here. So before starting, I would like to ask you a few questions just to understand what is the audience we have. So we will see in a moment the agenda for today. So how many of you use Power BI? All of you. How many of you use today Analysis Services 2017 or Azure Analysis Services? Analysis Services 2016. More of you. How many of you are using Analysis Services but only 2012 or 2014? Good. Okay, so this helps me understanding which are the most important concepts that I will have to transfer. I will not cut anything from my session, but of course the importance of certain topics could be different based on the audience. So what we're going to see today. First of all, I will introduce the DirectQuery feature in Analysis Services, in Azure Analysis Services and in Analysis Services 2016-2017. As you will see, there are no differences. The experience, especially the development experience, is the same. We may do some consideration about connection, but I would say that the differences are minimal. We will look at what happened when we use DirectQuery, because we will also see at the end why should we use DirectQuery or not, but I want to set the right expectations about the performance. And I will clarify that when we will discuss about what are the use cases where DirectQuery is good and what are those where it is not so good. Hopefully, the scenario could change in the future. Hopefully, coming features in a near or distant future will help us increasing the range of use cases for DirectQuery. So for this reason is important. Even if you think that today your scenario is not ready yet for DirectQuery, maybe that it will come one day, some feature that you will appreciate for your particular databases. However, we will spend some time trying to understand how we can optimize DirectQuery in order to get to the best performance. And as I said, beside a few differences in the data modeling experience, all the consideration about the optimization are absolutely the same also for Power BI. So I think that for those of you that think about using Power BI with DirectQuery, it could be interesting to see what are these features. I will show this slide at the end again, but there is a white paper I wrote with Alberto Ferrari, together with people in Microsoft, and in this white paper, we published this white paper 1 year ago, but this white paper is still up to date. So there are no particular differences that could affect what we wrote in this white paper. And this white paper contains the entire content of this presentation, plus probably more insights, especially for the optimization part. So if you want to understand how to create a model that has better performance, you will find a lot of information here. So What is DirectQuery? DirectQuery is an alternative storage engine that you can use in Analysis Services Tabular or in Power BI. The architecture of Analysis Services Tabular has two ways to store data of your database. The default technique is in memory. By default, when you create a new project, you create the project using an engine that we call Vertipack. You may have read a different name in the past, X-Velocity in-memory database engine. But because many events, many white papers and several pages in the documentation reference this as Vertipack, which was the code name of this engine developed internally in Microsoft. We reference this technique, this engine as Vertipack, the Vertipack engine. But the Vertipack engine is nothing else than the default engine you have in both Power BI, Analysis Services, Power Pivot, when you copy the data in memory and you have everything available in a compressed way in RAM with the best performance. When you use this engine, however, you are working on a snapshot of the data, which is the copy of the data that you made at a certain point in time. For this reason, we have to refresh the Power BI model, we refresh the Analysis Services Tabular model, or we refresh just one partition. However, whatever you do, you have data at a certain point in time. We call this a snapshot. With DirectQuery, we have a different scenario. We say to the engine, whenever you need to retrieve the data, send a query to the data source. Today, as we will see, this data source is limited to a number of relational databases, but this could change in the future. This is already different in Power BI in reality, but in Analysis Services, we still have support only for a few relational databases. The advantage of DirectQuery is that you don't have to copy data. You don't have to wait to transfer this data from the relational database to the in-memory engine. And so we say that you have data in real time. The latency between the data available on the relational engine and data available in your report is virtually zero. Because beside a few caches that you might have depending on your client, every time you run a query, the query runs on SQL Server or Oracle or Teradata. But of course, the query will probably be slower. Don't expect that just because you have a lot of money and you buy a big hardware, you can beat Analysis Services Tabular. Give me the same money, I will get the same performance, and with the difference, I will go to a cruise, I will get a nice holiday, and so on. So if you want to throw your money out of the window using DirectQuery to achieve the same performance of Analysis Services Tabular, you are free to do that, but I would like you to spend the money in a different way so that for the performance, if you can store the entire volume of data in memory, of course, Vertipack provides you better performance. So this slide is just a recap of the architecture. We can see here that we have the Analysis Services Tabular engine that receives a query and has to decide where to retrieve data. Depending on how you create the model, the data can be in memory or in DirectQuery. Problem. Today, when you create a model in Analysis Services, the entire model has to be set in either DirectQuery or Vertipack. You cannot mix the two. You cannot have, oh, I would like to have this table in DirectQuery and this table in Vertipack. Sorry, not yet. But I hope that this will be possible in the future, and this will open a number of new interesting scenarios. Today, we are not there yet. So what are the pros and cons of Vertipack? Basically, I already described that, but the pro is that we have better performance. Vertipack, better performance. No way. And we can also have different data sources for your data model. You can retrieve a few tables from one data source, one database, one connection to one particular relational database, but you can also retrieve other tables from a web page, from a SharePoint list, or whatever you want. It works. It just works. When you use Vertipack, you have to refresh data and you do a single query, a single scan of the source data, and of course you have a snapshot. The cons are that it takes time to transfer data. It takes time. You have to wait before the data is available on your data source. You need CPU to process data. This could be a problem because it has a cost. It has a cost in time, in resources, and so on. And you need enough memory to store the data. Now, you may have a larger database that doesn't fit in memory, but usually, if you limit the columns that you load to the columns that contains relevant data for your business, usually this is not a big issue. But when you want to enable the drill-through feature, getting the transactional level of the data, you want to see exactly the order number, the line number, all this stuff, it's very hard to compress those data, and it is very expensive. So, again, that would be expensive. I would like to have a mixed environment, not yet. So, the network will be the bottleneck because you have to transfer data, especially when you work on a different server. What about DirectQuery? DirectQuery has a few advantages at this point because we don't have to wait data. We can immediately retrieve the information up to date, up to the second. Why not? But of course, this has a cost. Performance is lower, which means that to achieve acceptable performance, you may have to spend money on your relational database. You have to create particular indexes. You may end up creating a column store index in SQL Server, which uses the same technology of Vertipack, but believe me, same hardware, you can expect Vertipack to perform much faster than column store index. Read the white paper. You will see interesting analysis of that. And the other limitation you have in DirectQuery is that you have to get all the tables from a single data source. You cannot mix different data sources. So if you use DirectQuery today, you needed to store all the tables in a single connection. Technically, in SQL Server, you may have different databases on the same instance of SQL Server, but usually we say all the data in the same database. Now, DirectQuery evolved over time. DirectQuery was already in Analysis Services 2014, and I asked at the beginning how many of you use that version, because please don't use DirectQuery in 2012-2014. It is just not ready. It is, the performance is unacceptable. There are many issues, and there are many limitations in the features that you can use in your model. Most of these problems are gone in Analysis Services 2016, because in Analysis Services 2016, we can use both DAX and MDX, which means that we can use both Power BI and Excel as clients for a DirectQuery model, whereas in a previous version, Analysis Services 2012-2014, only Power BI were an acceptable client because MDX queries were not allowed in DirectQuery model. The limitations about the formulas that we were able to use in DirectQuery are gone. So now we can use, in practice, everything we have in DAX. Of course, there are differences in performance depending on the functions that you use in DAX. So there are things that are not possible or not very, very fast. This is something that we will describe in the optimization, in the optimization part. But basically, I would say most of the features, 95% of the features you have in a tabular model, you can have the same in DirectQuery. So basically, you can do pretty much everything, including the security, and we will see demos about that. What are the supported data sources for DirectQuery? Today, the ones that you see there for analysis services. Power BI has probably something more, and we can expect that the same type of support will be available in analysis services sooner or later. If you want to get an updated list of providers supported in DirectQuery, you can reference the link in this slide, and of course you can download the slides. So, I promised that I would spend most of the time in demos. So, okay, I had to do the introduction, but from here and after, we will spend most of our time looking at how we can use DirectQuery. So let me go to the demo machine, and in this case, I start with a model that is a simple data model that I prepared in advance using the default Vertipack in-memory engine. What does it mean? Let's take a look. I have a simple data model, as I said. We have a number of tables here: date, sales, currency, product, promotion, and store. We have 3 measures here, very simple: sales amount, cost, and margin. So you see the margin is the difference. The sales amount is this simple, relatively simple calculation. We can remove this one. This was just a test. And the cost, same here. So this was something that I created to show a demo, and I forgot to reset. Okay, so this is my model. If I take a look at the diagram view, I can see that my model has relationships that defines how to relate the sales to date, to product, to currency, store, and promotion. And this model, at the moment, has this setting, DirectQuery mode, set to off. So what is this model? This model is a regular in-memory database. And what do you have to do to go to DirectQuery? You can simply change this setting. So in Power BI, you have to make a decision up front, usually, about do you want to use DirectQuery or do you want to use the in-memory, the import mode. Here you can change your mind. And so instead of keeping the data in memory, if I set this DirectQuery mode property to on, as you see, the model is updated, the window is closed, and the window is open again. What happened? Well, you can notice that there is a difference now. Before I changed the setting, I was able to see a preview of the data in this area. In this area, I was able to see the content of the table in memory. Now, Visual Studio doesn't show you any preview of the data once you switch to DirectQuery. If we want to see this preview, we will see how to manage that later. But the first time that you switch to DirectQuery, you don't see anything. And if you try to process the model, so I go here and I process all the tables. This is what happened. Nothing. Nothing. Because there is no data to import in memory. But if I open now Excel or Power BI, and I click here and I go in Analyze in Excel, please note that you have to set this full data view. Otherwise, you will not see anything. I will explain this in a moment. When I do this, then I can see that where is my Excel here? I have my model, I have my measures, and I can ask, show me the sales amount. You see that I have to wait a little bit more than usual, and I can split this data, for example, by product category name. And you see that now I will see my result in a moment. Now, I'm intentionally using, in this case, some query to retrieve the data from the data source that is slow down the performance. So I am showing you, I'm trying to highlight that every time I query the model, it's SQL Server that is answering the query. And because I'm using not a table, but a view that contains a number of stuff in the middle, this is slowing down the performance. We will see the performance better later, but this is just to introduce the problem. Now, remember, at the beginning, I had my model, I had my data in memory, but switching to DirectQuery, everything is gone away. But now, if my data change in SQL Server, when I refresh the pivot table, I see the updated numbers. I don't have to wait for the processing time. However, what happens if I change my mind again and I set the DirectQuery property to off again? Please pay attention to this. You have to select the model, and this is a property that you see at the model level. So when you are here in the Tabular Model Explorer, you may not find the DirectQuery property. So you have to go here, click here, and now I can set this to off. Now, as you see, once again, the model is closed, the model is open again, but I still don't see the preview of the data. The reason is that when you switch between DirectQuery off to DirectQuery on, any data that you had in memory is destroyed. What I can do at this point, I can refresh my model again. I'm just refreshing the workspace server at this point. At this point, I'm reading data from my SQL Server in this case. So in a few seconds, I have my data in memory, and now the preview is working again. This is just to explain you how to work with DirectQuery using Visual Studio for analysis services. You can switch back and forth, but every time you come back to the DirectQuery mode set it to off, you need to refresh your model because you lost the data that you had before in the workspace database. Of course, at this point I can test Excel again. Now my data is in memory. And of course, the performance is visibly better. You click, 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 everything is immediate because now we are using the in-memory engine. So when I go here and I choose products and I have this, you see that I don't have to wait those 1-2 seconds of delay. That sometimes with a larger database could be much more. But I will show you how to optimize SQL Server, so don't worry too much about the performance by now. Okay? So, back to the slides. So this is just a very, very quick introduction. Now, let's start to see something more. Quick recap. This is the property we used. So you will find in the slide the reference to this property, direct query mode. We set this property to on. When we did this, our data in the workspace database disappeared. And when you use the connector from Excel within Visual Studio to connect to your workspace database, remember to use the full data view because otherwise you will not see any data. And I will explain this in a moment. The thing is that when we are creating a model in DirectQuery mode, we no longer have a copy of the data. If we want to see in Visual Studio some data to test our measures, to test, to get an idea about what is the content, we have a way to create workspace database in memory, so a temporary area that has the same data model, but copying the data in memory, but maybe not loading the entire tables, but just a subset of these tables. How does it work? The idea is that we can have partitions, and in each table, we can define a specific partition that contains sample data. A partition that contains sample data is only used when you specify in the connection string a particular parameter which asks to the Analysis Services Tabular engine, please show me just the sample data. Don't use DirectQuery. At that point, you are using the in-memory storage engine. You are using Vertipack. But of course, now we have to create a more complex data model. The other thing that I will show you is that we can switch between DirectQuery and in-memory even after we deploy the database. So you may also decide that you develop in-memory, but once you deploy, you can change this setting, switching the entire model to DirectQuery. Be careful because a few features are not available in DirectQuery. So the risk of developing an entire data model using default in-memory setting and then changing the DirectQuery setting after the deployment is that you may have used some feature in your model that is not supported in DirectQuery. We will see this later. And this switch will not work. If you are using Visual Studio and you set the model to DirectQuery, of course, if you try to use a feature that is not supported, you get an immediate feedback from Visual Studio telling you, you cannot do this. Okay? So, once again, we go back to the demo machine. And I just have to change the model that I use for this other demo. And I have another project that I prepared here, which I called with sample data. So this is the same model that we have seen before in terms of structure, measures, and so on. The difference is that in this case, this model has, in each table, several partitions. Let me show you what is the content here. You see that basically I had at the beginning only one partition, the default one, and now I have two partitions. The two partitions are different, 1 and 2, and let me show you how I reached this point. So I go back to the previous model, just for 1 minute, so that I can show you how I usually create this second partition. So this is the model that we have seen in the previous demo. If I go in the table partitions dialog box, you see that I have a single partition here. So an easy way is using copy. But of course, if you use copy, now you have one partition in DirectQuery mode and one partition in DirectQuery mode and one partition that will be a sample partition with the same data. So what we do is we probably want to reduce the amount of data that we have in this partition by applying a where condition, where blah, blah, blah. This is the technique that I used before. The other thing that I did, actually, I had to modify. So now I go back to the sample partition demo. So I go here. So this is just to explain how I created the second partition. And you see that there is this button here enables you to choose which of the partitions you have is the partition that will be used for DirectQuery, and which one is the partition that you will use for the sample data. Now, you can use exactly the same query. You can use the same select star from table in both, if you want. But of course, at that point, your sample model will be identical to the DirectQuery. So if you have 100 million of rows, when you process the workspace database, you have to read 100 million of rows. It's up to you. Now, one thing to keep in mind, you probably, if you want to use this technique, you probably have to repeat the same operation for every single table in the model. It's up to you to define what to include in the sample partition. For example, in this case, if I switch to the other tables, you will see that for the other tables, I simply have exactly the same content, because this is like a star schema. I have dimensions and fact table. The fact table is usually the only large table in the model, and the other tables are relatively small. The dimensions are relatively small. So what I did in this case, I copied all the dimensions, so without making any change in the query, and I only applied a where condition, getting only the first day of the month in the sales table for the sample partition. So the idea is that when I use Visual Studio, I have around 3% of the rows of the entire database, because I want to have a faster way to refresh my workspace database, and I also don't need so much memory to load my data in memory, to load my data in the workspace database. But of course, when you do that, you have to be aware of what you're doing. Why? Well, let's take a look at the numbers. Now, remember, what I'm seeing here, this is my sales table in the workspace database. In this database, I loaded 400,000 rows. How many rows we have in the real physical table in SQL Server? 12 million. I'm loading only the first day of the month for the data that I have in this table. Which means that if now I try my model using Excel or Power BI, so I go here and I click this and I connect using the sample data view. This connects to the sample data, so I will see only my 400,000 rows in the sales table. So now in Excel, when I include the cost and sales amount, and I divide this by, for example, product category name, these are the numbers. And you can see that the grand total of the sales is $122 million. This is my sample data. Now, what happens if I keep this Excel open? Why not? I go back in Visual Studio, and I ask to open another Excel window, but this time I switch to DirectQuery. Now, I will open the same pivot table in Excel, actually in another file. I can include the same measures. As you see, the performance is a little bit slower, but when I already see that the numbers are different, but when I go to the product category name, here is what I see. In a moment, you will see that I have a table that has the same structure, the same type of report, but with different numbers. I show you both. Here we go. You see that this is a very much bigger number than this one. Okay? Which makes sense, because now I'm querying the entire data model. I see all the data. And of course, the numbers are different. So keep this in mind. If you use the sample data and you reduce the data set, you will not see the same numbers in this test mode. Now, usually, this way of looking at the data is something that you should use just for test purposes. But technically, nothing stops you to deploy this model in production and to make the users able to change the connection string and choose between sample data and the full data. Because what I'm doing in Visual Studio is simply changing the connection string passed to Excel. However, if you use Power BI as a client, today it is not possible to customize the connection string in Power BI. So in Power BI, you will always see, in a live connection, only the data in DirectQuery mode. There is no way today in Power BI to change the connection string that is created to connect to analysis services. Okay, so if you remember, I said I could also change the DirectQuery mode after the deployment. How can I do that? In this case, we use another tool, which is SQL Server Management Studio. It is a tool that is completely free. You can download from the Microsoft website. And this tool enables you to manage both analysis services and SQL Server. In this case, I connected my SQL Server Management Studio to the instance of analysis services. I see here the list of all the databases. And I go in this database that I deployed before. This database, First Steps DirectQuery, is a deployed version of my initial project that I deployed. In which way? In DirectQuery, yes. But actually, then I deployed this database in another way. And I want to show you that the setting that was called DirectQuery mode in Visual Studio, once you go in SQL Server Management Studio, has a different name. We need to write books. You know, Microsoft helped us to describe why they use different names to do the same thing. So here, import means DirectQuery off. DirectQuery means DirectQuery on. Okay, so you have to use this property. Now, what happens if I use this property? Let me show you 1 second. So before I change the property, let me create, maybe in Power BI this time. So now I open a new instance of Power BI, and this instance of Power BI will be connected to analysis services, to this model. So I go here, get data, analysis services. I specify here my instance of analysis services. I'm showing you the demos using Analysis Services 2016. I will highlight when I'm using features that are specific of 2017. So at the moment, anything I'm doing now is available in all the versions of Analysis Services 2016, 17, and Azure Analysis Services. So when I connect live here, I can see the list of all the databases, and I connect it to this DirectQuery model, First Steps DQ model, which in reality at the moment is loaded in memory. So the entire data set is in memory. So if I select category name and sales cost and sales quantity, and I increase a little bit the font so it will be easier to read in the room. Now this is my data in memory. Now I go back to SQL Server Management Studio. I change this connection here. So I go in, oh sorry, I don't do this. I have to go here, Properties, and I go here in default mode, and I set this to DirectQuery. And I click OK. This is also possible in a PowerShell script if you want. This is possible also in an automated way. So it's not necessary to do this in SQL Server Management Studio. What I wanted to show is that it is not necessary to do this in Visual Studio and then deploy. You can change your mind later. Now my model is in DirectQuery, which means that if I go back here and, for example, I change something, so now instead of category name, I want to show this by subcategory name, this one. You see that Power BI think, because the query is solved by SQL Server, but at the end I have my data. Okay, now I change my idea again. So I go back to the database properties in Analysis Services here, and I change this to import again. Remember, I can switch between DirectQuery and import mode, but when I do that, my database now is empty. So what I expect if I go back to Power BI and I refresh this model, actually I don't see anything. Oh, nice. Is so bad? Okay, probably because there were some reference to some other measure, but no. Interesting. Okay, right. I have to refresh. Okay, yes. This is interesting. Okay. The model is empty. There are, depending on the calculation that you do in DAX, something could not work. How can I fix the problem? So even if I don't include any measure, I simply see that my table is empty. You see that there is no data here, because every table is empty. The solution is simple. I can go here. I can refresh the model by doing a process full of the model. Once the process is completed, my data is available again. This demo is just to remind you that every time you switch from DirectQuery to in-memory database, you have to refresh the model. You have to load the data in the memory again. At this point, if I go back here and I refresh the model, you see that I have my categories, I have my measures here, and I can increase the size of the font, and I can show you the numbers again. So actually, the model is now in memory. It is also faster. Okay, this was the demo. Okay. Back here. Now, this is what we did. We created a sample partition, which enables us to use Visual Studio to test the data, to work with some data that is visible. We can change the definition of the database between DirectQuery and data in memory using also SQL Server Management Studio. You will find in the documentation also techniques to do the same using PowerShell, TMSL, and other tools. We mentioned that there are limitations in tabular models for DirectQuery. So actually, there is something that we cannot do. First, we cannot create calculated tables. You cannot create a new calculated table in the model. Second, in DAX, you basically can do everything from the point of view of the measures and of the calculated columns, even if, depending on the function that you use, you may have a translation of the calculation into the SQL Server, into the SQL query, or the calculation could be performed by the in-memory engine. If you think about this, there are implications. If I implement a calculation in DAX that requires the data to be loaded in the formula engine to perform a scan, you might have to copy a large data set at query time, which is a bad idea for the performance. So yes, it works, but the performance could be very different. So you may want to change your DAX formula in order to try to push the calculation into SQL Server, reducing the amount of data that is transferred from SQL Server to Analysis Services. The other restrictions we have is that in the row-level security filters, you cannot use a number of functions. I think the most important one is that you cannot use calculate, for example. So there are functions that you cannot use in row-level security filter, and you cannot use in calculated columns too. That's another problem. The detailed list of these functions is at the link that you see in the slide. What about MDX? The limitation you have in MDX, I mean, Excel works, right? Excel works. We used Excel in the demo that I shown you before. But you may have not noticed that there is a difference between the features that I have in Power BI and the features that I have in Excel. And the most relevant one is this. The table product has a hierarchy. The table product has a hierarchy with product, subcategory, product category, subcategory, and product name. This hierarchy is not visible in Excel. So Excel, because Excel generates queries in MDX, Excel will not show me the hierarchies. So the hierarchy, when I use Excel here, you see that products has products has the hierarchy now because I'm connected in this case using the import mode. If you remember, we made the switch to the import mode in the last demo. But if I create a new Excel workbook and I connect, let me check what is the version I have here. So properties, I have now import. So I set this to DirectQuery again. So my first step, DQ, is DirectQuery now. I go back in Excel. I connect to this database. So get data from Analysis Services. And I do in tab 16. I want to connect it to the first step, DQ, finish. So this is the same model that I have in Power BI. But if I go to the product table here, you see that the product table shows me all the columns that I have in the product folder, display folder, but it doesn't show me the hierarchy with the 3 levels. So this is the limitation, strong limitation, we still have today for Analysis Services in DirectQuery. Then there are a few other limitations in MDX, but these are not so important. The biggest one is the lack of the hierarchy. Now, once you switch to DirectQuery, of course, in terms of optimization, you have to think about, you no longer have to optimize Analysis Services, you have to optimize SQL Server. However, probably what you do in DAX and in your data model will affect the way the SQL query is generated, which will affect the performance at the end. What can we use to analyze what is going on? 2 tools, SQL Server Profiler and DAX Studio. And I will show you these tools in the next demo. So, first of all, we want to understand what is going on when we query this model. Okay, we can start from here. This is Excel connected to a model in DirectQuery. Wonderful. So now I go in my SQL Server Management Studio, and here in the tool menu here, you can open SQL Server Profiler. When you open SQL Server Profiler, of course, you can connect to SQL Server and see what is coming to SQL Server. But in reality, there is a simpler way to analyze what is going on in Analysis Services, which is I connect to Analysis Services, and I have here, I define a template with DAX query trace. Okay, let me show you how can I create this template at the beginning. The basic idea, if I start from a blank template, I have no events selected. What are the events that are relevant for analyzing what is going on in DirectQuery? Well, basically we have query end, which is the event that tells you there is a query sent to Analysis Services. You will find here MDX or DAX queries. The internal process of the query will have to retrieve data from the storage engine. So we can, for example, capture the DAX query plan even if you have an MDX query. If the query is sent to a tabular engine, what you see is a DAX query plan, even if the query is MDX, I know. Let's call this query plan. And then we have DirectQuery end to analyze the query in SQL sent to the data source, even Oracle or Teradata. But if you want to also analyze the queries in memory, you can also use this storage engine query end, Vertipack storage engine query end. So when you see Vertipack, in-memory engine. When you see DirectQuery, the DirectQuery engine. So once you create this the first time, a good idea is to save the template so that you can, DAX query. And I save my setting, my list of events that I want to use. This is the technique that you can use in SQL Server Profiler to do this. So now I create a new connection, and I reuse my DAX query trace template that I created in advance. This template has the same events that I've shown you. I also included the query cache match because I use this for doing a more complex analysis. And now I run the profiler. So let me set the profiler here and the model here. Now, imagine what? If I go to the pivot table here and I click on a sales amount measure, I see the number. But after a small delay, I also see what happened in SQL. Actually, in Analysis Services. Analysis Services generated a query plan, has a query end. The query end contains the query in MDX. This query is in MDX. And internally, there is a DirectQuery end event which contains the query in SQL. If you copy and paste this query in a connection to SQL Server in Measurement Studio, you can actually see the same result received by Analysis Services. You have to optimize this query. Basically, you have to optimize the query. However, what happens when I start creating a more complex query here? For example, I include the category name in the rows. Now, you will observe that a single query end event, a single MDX query, generated not only once, but 1 and 2 direct query end events. So in other words, a single DAX or MDX query can generate more than one query in SQL, because you may have different requests to the storage engine for the same. The reason is that basically we have different granularities here. If you look at this code, this is the calculation made at the category level. This is the calculation without filtering the categories. You may think, Marco, should be the sum. It depends on the measure. It depends on the referential integrity. It depends on the fact that the join has all the data in the other table. So if you think about the problem, there are a number of details to consider. And so the engine does something that is consistent, but again, if you want to enter into the details of the optimization, read the white paper, because we explain these details in, with more details, yes. So this is how I use the SQL Server Profiler. Now, what if I have this situation? Imagine this. I open Power BI. I open Power BI and I want to start using Power BI. Now the problem is that, yes, technically I can capture the query, but you will see a lot of noise in the SQL Server Profiler. It could be hard to filter all the events that you want. Let me show you what I mean. So I connect to Analysis Services. I go to my tab 16 model. I connect it to the first step DQ that I created before. And now I go here in sales, I include the cost, I include the sales amount, and you see that I have to wait some time because this query is going through a connection that is using views that is not particularly fast. So let me enlarge this a little bit. So I have my numbers here. I can also include something else. What is going on here? How can I? Okay, if I go to my SQL Server profiler, you see here my events. You see this is a DAX query this time. If I change this, including the product category name, for example, not here, but here, move this. I want to do this. If I do this, you will see that at the end, I will see the execution time here about how much time we spent here, 5 seconds and 700 milliseconds. This number is in milliseconds. This is the DAX query. These are all the SQL queries that I received. And please note this. Please note that many times there is a top and a number. This number can be changed. I will show you a slide later. Because sometimes the calculation will be performed in the formula engine, and this could require getting a lot of data from the relational database. So analysis services put a limit, because if there are too many rows, it doesn't want to work too long. But of course, if you receive exactly that number of rows, what does it mean? There are other rows that have not been read from SQL Server. So in that case, you will get an error. So you will get an error saying this calculation is not possible. It depends on the calculation. So you can have a billion of rows in a relational database and use DirectQuery. But if you write a particular complex DAX formula, you may create the condition for which the entire 1 billion rows should be loaded in memory to solve the calculation that you wrote. And this, of course, is not possible. Again, this is a part of the optimization if you have to create complex calculation. But this number can be changed. And in fact, I will suggest you to change this number to the size of the largest dimension that you have in your model. For example, if I have 20 million of customers, probably that number is not good enough. Because it is too easy to create a report where you put customer name, sales amount, sort by. It crashes because it tries to load all the customers into the engine of analysis services. So be careful. The other tool that I want to show you is DAX Studio. DAX Studio is a tool that in reality is designed to optimize a single query. So when we want to analyze what is going on, we may use DAX Studio in this way. But I want to show you a feature that will be available soon, because I'm using a version of DAX Studio that is not released yet, but I think next week you will see this online. And we have this button now, which is all queries. I want to capture all the queries from analysis services. So at this point, this is only filtering the MDX or DAX queries received by analysis services, which means that now if I remove, for example, the category name here, and I include, let's say, the product color, let me remove this and put the product color, you will see in a moment the product color here, and if I didn't make any mistake, I should observe what is going on. I didn't click product color. Sorry. Here we go. Now is running. As soon as this completes, I will see my product color query appearing here, hopefully. But maybe I made some mistake. Let me check. Yes, I forgot this. Okay, sorry. Let me try again. So I will explain this later. There is a small bug that we will solve. So instead of the color, I could use the brand. So I have a different query. I'm trying to use a different query because Power BI uses a cache, and so it will not repeat the same query twice. Now I see my query here. Now imagine this. You connect to a server, and there are a lot of queries generated by many users. Here I have the duration of the query, so I can immediately see, oh, this query waited for 5 seconds. So if you double-click this query, you have the query here. And now what you can do, you can stop this capture. You can go in options and enable the direct query trace. And I can run this query by clearing the cache before. So I'm making sure that the query will be executed by SQL Server. And I enable the server timings. Basically, I'm doing the same thing that I do in SQL Server Profiler, but once I run this, I will see here a detail of how the time has been spent in the formula engine and in the storage engine. And the storage engine queries, in this case, because I'm using DirectQuery, are queries in SQL. And so I see that there is a query that runs in almost 3 seconds, and another one that runs in 3 seconds, and this one just in 1 millisecond. Now it's up to you. You as a DBA, as a SQL Server DBA, you have to get this query here and try to optimize it. And you notice that this query has a left outer join. Now, I don't enter into the details about how to optimize a SQL query, but sometime for certain queries, maybe an inner join could be better. And I will show you this in a moment. We can optimize the model by saying, well, I can assume that every data that you have in the fact table has a correspondent row in the dimension, which hopefully is true for a star schema. And this will enable to generate a different and more efficient SQL query. Okay, so let me go back to the slide. Come on. So we have seen that using different clients, we have a different experience because the Excel pivot table generates MDX. And when you use Excel, there is no cache made at the analysis services layer. Whatever you do in Excel, it generates a new query to analysis services. But analysis services could do a cache at the MDX level. So sometimes you may not see the query going to SQL. When you use Power BI has a cache at the client level. So if you don't hit refresh and you go back and forth with a slicer, when you go back to a configuration that you already used, you are not generating new queries. So be careful about looking at the generation of the event corresponding to the slowest combination of slicers that you created the first time. However, when you hit refresh enforces sending the query, the DAX query, to analysis services. Depending on the configuration, you may hit this limit. The limit is, I forgot, it's not 10 million, it's 1 million. So the limit by default that you have in analysis services is 1 million rows of rows returned by SQL Server, Oracle, Teradata. So a DirectQuery query does not return more than 1 million rows by default. However, if you know that your model has 5 million customers, 2 million products, there are too many combinations of selection made by the user, even in Power BI, that will generate an error in the query. How can you work around? You have to open the msmd srv.ini file. You need SQL Server on premises today to do that, and Azure Analysis Services doesn't allow you to change the setting by now. And you have to change exactly this setting that you see described here. If you look for this max intermediate row set size on MSDN, you will find also the documentation about that. The suggestion is set a number that is just higher than the largest dimension that you have. So if you have a dimension larger than 1 million rows, probably you need to change the setting. Now let's talk about security. The good news is that security just works. You set the row level security in analysis services, and all the filters that you apply in a role are applied to the queries that are sent to SQL Server. So you might have a connection to SQL Server, and SQL Server doesn't know your users. Analysis Services is a trusted user from this point of view, but Analysis Services make sure to inject the where condition that you want for a particular security role. In reality, we also have another option. If you already have, in this case in SQL Server, Microsoft SQL Server, you already have a row level security implemented in SQL Server, you may rely on the existing security, saying to Analysis Services, when you connect to SQL Server, impersonate the same user connected to Analysis Services to SQL Server. At that point, it's up to SQL Server to show only the data that that user should see. So let's take a look at how we can implement those settings. So in Visual Studio, here I have, let me close this model. I have a model where I have the security roles defined. So in this case, the model is always the same. In this case, the difference is that if I go in this menu, model roles, I defined 3 roles, 1 for each continent. Then, of course, every user will belong to 1 or more of these roles. It's a simple configuration. Every role defines a filter in the store table. The store table has a column called continent, and I define a very simple rule, store continent equal to North America for this role, Asia, and Europe. Okay, so these are the 3 roles. Once you have this model, so this model is defined in DirectQuery mode. Let me check that I have a DirectQuery mode on here. Now I want to test this model, so let me check that I have here. I connected to this, and I have this in the workspace database here. Okay, perfect. So I cleared this window, and I start a connection using Excel, because in Excel I can simulate a user that belongs to, for example, Asia and Europe. So I expect this user to not be able to see data in North America. And of course, because I want to see the result in DirectQuery, I enable the full data view because I want to see what happens in SQL. At this point, Excel opens a new connection here, and I click on sales amount, and let's include the store country, for example. So country region here, and I have my data here. So this is my data, China and Germany. I don't see United States. Why I don't see United States in this case? If I go to the SQL Server profiler, you can see that there are a number of events here, but every DirectQuery and event has here this where condition. Now, depending on the version of analysis services that you're using, the equalage function could be here or not. If you are using analysis services on Azure or analysis services 2017, the code written for this condition is more efficient than this one generated by analysis services 2016. Okay, so it just works. You don't have to worry about this. However, in case you say, but I already have this logic implemented in SQL Server, we use Active Directory, the users are the same, you can ignore this security in analysis services. The only thing that you have to do is not defining security roles, but at the connection level here, at the connection level here, I'm opening the properties of this connection, and the impersonation has a setting which is current user. If I set current user, what happens? When Excel connects to Analysis Services receives the token of the user in Active Directory and transfers this token to SQL Server, impersonating each single user. Of course, this will increase the workload to SQL Server and will decrease the ability for Analysis Services to use the cache, but security first. So this is an option you have. You can also change this instead of in SQL Server data tools, also in SQL Server Management Studio. The setting is here. You go in the connection, right-click properties, and here in the impersonation info, you can set this to credential of the current user. So these are the settings that you can set to get the security, the row level security from SQL Server. Okay, so security done, perfect. Finally, what if we want to optimize DirectQuery? As I said, the white paper goes more in detail. We will see only the high-level things. First of all, we have to make sure that we use the functions that are more optimized for SQL. What does it mean? If you use DirectQuery, probably you want to push most of the calculation and most of the aggregations to SQL Server or to Oracle, because otherwise what you obtain is that a lot of data has to be transferred to analysis services that has to do the aggregation. And the transfer of the data becomes the bottleneck of your query. So in order to avoid that, you have to use the functions that can be translated into correspondent calculation in a query in SQL. Another thing that we have to make sure, as I said before, left join sometimes is not a good idea. It could be better to use an inner join, especially if you're using the column store index too. And also be careful using bidirectional filters. Bidirectional filters are supported in DirectQuery, but from a performance point of view, they could be a very bad idea. So use them only when you actually need them. And of course, how can you optimize SQL Server? Okay, any SQL Server DBA here can probably tell more than what I can tell you, but column store indexes and indexed views are two powerful tools you have, at least in SQL Server, to optimize the queries. So let's go to the demo again. And in this case, I open another model I have here, this one. And in this model, I have a few calculations in DAX that I want to comment. This calculation, sales amount original, is written in the way we usually prefer in DAX. In DAX, in a model in memory, we try to avoid having columns that have redundant information that we already can obtain from other columns. If I can calculate the value of each row in the sales table by multiplying the price by the quantity, there is no reason when I have the Vertipack engine to create a line amount column that has the multiplication of the two. Technically, you can do that, but from a performance point of view, is not a good idea, unless you have a very large amount of data. But usually with 1 or 2 billion rows of data, it's better to use this approach. However, if you use this approach, what happens in your query in SQL, you will see the query in SQL that contains the multiplication of the two columns row by row. And believe me, even if you have the column store index, the way this calculation is performed is much less efficient than the same equivalent calculation in Vertipack in analysis services. Which means that when you have, and when you need to optimize this calculation for DirectQuery, it could be a better idea having the column that contains the multiplication quantity by unit price in SQL Server and just a sum one column. So the idea is that at a certain point, this is true also for Vertipack. It is true also in Vertipack that if you have 10 billion rows, this is faster than having two columns. The difference between Vertipack and SQL is that in Vertipack, the trade-off is around 1-2 billion rows. In the column store index in SQL, it is much lower than that. You probably want to use a single column when you have just a few, 20, 50 million rows probably. You have to measure this, you have to do your benchmark. Of course, the performance could depend on the hardware, but it is something that you may want to consider. The second thing is that we talked about the join. If I have, let me open a query that I have in DAX. I just have to find the query. It is here. I open this query, and let me describe this in a moment. So I have to use this model here. Let me check where the model is deployed. Okay, so it is contours DirectQuery, so I have to connect here, and I have to connect here. Okay, perfect. So this is exactly the workspace database that I'm using in Visual Studio. So if I execute this query here, this query is using the technique quantity multiplied by net price. If I enable here the server timings, that will show me the queries in SQL sent to SQL Server, I will see that this calculation is translated into the SQL query. Okay, so it is SQL that is solving this query. What if I take a look also at the joins? This is the other problem. You see the problem. This left outer join, if I know that every row in the sales table has a product key, a date key that exists in the dimension, I could use the inner join. That usually produces a better execution plan. So how can I tell to analysis services, you can use inner join? Trust me. You can obtain this by using a property that you have in the relationships. Every relationship in the model has this setting, rely on referential integrity. This setting exists also in Power BI, by the way. And if you know that you can trust your model, it is a good idea to set this property in all the relationships when you can bet that this is always true. So we are telling that there are no rows in sales with a currency key or a product key that doesn't exist in the corresponding dimension. The engine doesn't have a way to validate what I'm assuming. So my assumption has to be true, otherwise I will get wrong data. I will hide, with the inner join, I will hide the rows in the sales table that have a product key that is not valid. Now, if I repeat my query again here, I will see that my left join is now, so I'm executing the same query, but my left join is now an inner join, which can produce better performance in SQL Server. If you want to get a good performance in SQL Server, usually it could be a good idea to, for example, create column store indexes. And by creating a column store index, I can do many things. And for example, another good idea could be materializing the columns that contains calculation so that you will increase the speed, especially for the column store, because you don't have to calculate row by row, the multiplication, the division, or blah, blah, blah. You can store the result row by row. This is much faster in SQL. It is expensive. You have to spend more memory, more time to process, but actually this could be another optimization that you can do. Okay, so let me go back to the slides. When should we use DirectQuery? Basically today, there are two scenarios. You have a small database that is updated often. So the performance is not an issue. Database is small, but we need to reduce the latency between data in the database, in relational database, and the performance. And data available in the report. So data is always up to date. The other scenario is you have a so large database that cannot be fit in memory. Now, technically, you can use DirectQuery in this scenario, but believe me, it will be not easy to use for a user in Power BI or in Excel, because every time you do something, you have to wait 10, 20, 30 seconds, minutes. Because if you think about something that cannot be stored in memory in a compressed way, you probably are thinking about something around many, many, many terabytes. Remember this, when I have a 1 terabyte database in SQL Server, compressed in memory analysis services, it could be 10 gigabytes if I do all the proper work in optimization. So actually, if I cannot store something in a database with 100 gigabytes of RAM, I have 100 terabytes of database in SQL Server. Now, you run a query, you group everything. I expect performance to be not good unless you do a lot of optimization, a lot of index views, and so on. So it could be very expensive. It will be nice having features in the future that will allow us to create hybrid systems where we have Vertipack in memory for aggregated data and detailed data in SQL. So, if you want to use DirectQuery, you can use them in 2016, 2017, and Azure Analysis Services. It is a better idea to set the DirectQuery mode at the beginning so that you will not use features that are not supported in DirectQuery. And then, of course, you have to optimize your model for DirectQuery. There are a few differences compared to what you do to optimize a model in Vertipack. The use cases are those that I already explained. I remember that this white paper provides you all the information about how to optimize and use DirectQuery in analysis services. Please remember to evaluate this session. Please give your feedback. It is very important. And of course, I will be here for a few minutes. If you have any question, probably I have to leave the stage to the next speaker. Thank you very much for attending this morning.